let's start off with a question. And the question is this. What does a user at the end of the day, what do they want from the network? We can imagine a user like Bob who's sitting at their computer with their favorite browser, going to www.myfavoritesite.com. They press enter. What is it they want from the network? So most of the time, I think it's just they want the network to work. And I would totally agree. Having a functional network is great. And behind the scenes, they're blissfully unaware of all the cool stuff that happens, the layer 2 switching for the frames, the IP routing with the packets. So in this nugget, what I'd like to do is chat with you about what are the defaults? Like, what does a Cisco router know by default as far as how to reach networks? How can it be trained? And then I'd also like to introduce you to a very strategic way that you and I can go through it together with some hands-on practice to reinforce all the skills regarding routing. Let's begin. So let's imagine that we just opened a box. We pulled out a Cisco router, and there it is. And let's call that router, we'll call it R2. Fantastic. And that router has two interfaces. There's a 0/0 on the left and a 1/0 here on the right in the topology. And if we power it up, but we don't make any configuration changes, what, if any, routes exists? Now, when we talk about routes, and I'm also going to add IP version 4 routes, a route is simply referring to a network, sort of like a street name. Another word that I've often seen when we talk about IP routing is the word prefix. So if we ever see the word prefix, think of it like a network or a street that the IP router needs to forward a packet to. Now, the question, going back to the original question here, is what routes does a router know about by default? And the answer is a big goose egg. It knows nothing. It doesn't know how to do anything until we start to configure it. And there's three major categories of how a router can be educated regarding reaching networks and how to forward packets based on their destination IP addresses. One option would be directly connected. And here's how that works. Imagine that we have a house or a condo or an apartment. I'll put a nice roof on there. Fantastic. And that dwelling is connected to a street. And let's go ahead and call this street Elm Street. Great. So there's ELM. So this is like 45 Elm Street. Now, if we talk to the people who lived at 45 Elm Street and we said, hey, do you know how to get to Elm Street? They would look at us funny because they would say, well, yeah, we know how to get to Elm Street. We are directly connected. That's the street we live on. We just go out our driveway about 10 feet or 20 feet or whatever it is, and boom, there's Elm Street. Well, the same thing happens on a router. If we have an interface and we bring the interface up, which is important if you want it to work, and we give that interface an IP address. So let's say we go into that interface and we configured an IP address of 10.23.0.2 with a 24-bit mask. At that moment, let me put this in a different color here. At that moment, this router believes it knows how to get to the 10.23.0 network based on this mask because it's directly connected. So that's one way of having a router being trained on how to reach a network, is directly connected networks through its own interfaces. Okay, what about networks that are not directly connected? So let's go ahead and add another router. In fact, I'm going to clean up this screen just a little bit, get my eraser tool out, and let me take out that bad boy. And also, we're done with this house, so I'm going to remove that as well. Fabulous. So let's add another router. We'll add router 3. And router 3 has an interface that is directly connected also to the 10.23 network. Now, the only reason it believes that is because we brought that interface up and we configured an IP address of 10.23.0.3, for example, on that interface. So this router, router 3, believes that it's also connected to the 10.23 network, just like R2. So those could both be connected to the same switch and the same VLAN, and they would have direct connectivity with each other over that same network. But let's imagine also that R3 has access or is directly connected to another network. Let's do 192.168.1.0. And the reason that R3 believes that is because it has an IP address. Let's call this gig 1/0, because it has an IP address on this interface that's in that network. Maybe it's 192.168.1.3 with the 24-bit mask, and that's why R3 believes it's directly connected because of the IP address that we have configured on that interface. So the reason I added this router is that leads us to another method. So one method of learning routes is directly connected networks, and another option, I'll put it over here. Number 2 is we could statically configure routes. And it would go something like this. We would configure manually R2 and say, dear R2, if you ever need to forward a packet to the 192.168.1 network, have no fear. Even though you're not directly connected to it, you can go ahead and simply forward that over to R3, and now it's R3's problem. That's the attitude. It's like hot potato with IP packets. Forward the packet, let the next guy worry about it. So an example of a static route on R2 would be to get to 192.168.1.0, the next hop that R2 should use would be 10.23.0.3, which is R3's 00 interface. So once that frame is then sent over to R3, R3 would de-encapsulate that, look at the destination IP address, and then continue making a forwarding decision as best it could. So we've covered two options for learning networks. We have directly connected, we have static routes, and the third option, and probably the most prevalent, is to go ahead and use dynamic updates or dynamic routing. And a good example of that would be a routing protocol. It's like R2 and R3, we give them permission using the same routing protocol to talk with each other. So in the background, like, hey, how you doing? Hey, I'm good. How you doing? Good. Hey, guess what? R3 says, I can get to the 192.168.1 network. So if you ever need to get there, you have the information that you could forward it my direction, and I would take care of it for you. And there are several options for dynamically learning updates in an IP network, but the primary method is using a dynamic routing protocol. And we'll cover that as well as a separate skill. So in this video, I wanted to share with you that by default, a Cisco router is not too valuable because it doesn't know how to get to anything. We took a look at three specific categories of how it can learn. Directly connected networks. Boom. I live on network 10.1 based on my IP address. Congratulations, you're there. 2, statically configuring routes. Manually configuring and telling a router to get to this remote network, here's your next hop or here's your exit interface so it can forward packets. And then third, the category is dynamic. So hold on to your socks, because in the very next video, what we get to do is we are going to take a topology, a network topology, and we're going to build it from scratch. And then we're going to start implementing directly connected routes so we can see it and feel it. And then we'll start adding these static routes on top of that for full network connectivity. So we'll start all that process in the very next video. So I'll see you there in just a few moments. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.